Hello everyone, welcome to Western Dev. And if you have been following me along, you could see that I have made a multiple RAG-based PDF chatbots application. But all of them are pretty much with the same use case, right? You will upload your PDF, you will convert those PDF chunks into some vector embedding, and you'll ask some information from that. But those are, as I said, those are all from kind of similar use case. So now it's time to explore some different use cases. So in this video, we'll be building one Shop Assistant Chatbot, or you can say Shop Catalog Chatbot, whatever you want to name it. And here what we'll have, like imagine as a shop owner, I'll be having a database, I'll be having a knowledge base of all of my products, of their brand's name or the description. So let me just show you first. In this CSV file you could see, let's say as a shop owner, I would have this product name, the brand, gender, price, description, primary color. I'm just trying to show a pretty general use case of it. Okay, so what we'll do, we'll upload this knowledge base into our vector database, and for this video we'll be using Pinecone DB. Okay, and after uploading into our vector database using Gemini API, using Gemini, we'll get to retrieve all our relevant information as per user's query. Okay, so that's being said, so before showing you the workflow or the architecture that I generally show in my every video, let me just give you the demo first. Okay, so here is the CSV you could see. So we can ask some question like related to this. So we have this skateboarding shoes, so let us ask some question. So let us ask um what are the shoes are relevant for skateboarding, so let's see the answer. Alright, you can see, well, for skateboarding, the SK8 High Pro 4 sounds like a great option. They are specifically designed for skateboarding, being water, all those things. And they're also providing me the price of it. So they are priced at 7,999. Okay. So let us ask some other question as well. That how many do you have? Let's see if it can give me the answer or not. Well, we have at least two skateboarding shoes. We have SK8 High Pro 4, which are this, and we have old school as shoot low stop option, and if it's real answer for that, let me just show you. So you could see we have our old school, this one, old school light 3, old school, and SK8 is this one, right? SK8 High Pro water resistant skateboarding, which is 599, right? We should have another thing. This is also SK8 High MTE, all this thing. Okay, so these are the thing. As per my knowledge base, I'll get these answers. Okay, so this is what we'll be building. So now let's see the architecture and the workflow of it. Okay, so before we dive into the code, let's break down how this chatbot actually works behind the scenes, right? So let's say a user types that what's the cheapest main shoes available. So first, and you could see in the funnel, right? So from the funnel's starting position where we will be passing our user query. So let's say first we convert that query into a numerical vector using any embedding model. Okay, now then this query vector is then sent to our vector database, which stores vector representations of product data that originally came from a MySQL relational database. Once the vector database finds the most relevant results, like a product description that closely kind of matches the query, it sends the context back. Now here is the RAG. We take the retrieved context from my vector store and we combine it with the original user query and feed the whole thing into a LLM like Gemini or GPT. Then the model uses both the pieces and like the query and the related product information to generate a highly relevant human-like response. So that's my RAG query processing funnel. Okay. Now that you understand how the flow works, let us break down the core technologies powering the chatbot, right? So at the center, we are using RAG, Retrieval Augmented Generation, right? Now the first thing is that blue boxes where we have MySQL. So the question comes, where is the data coming from, right? So we start with our MySQL relational database. So here we'll be storing our all soft information like product description, pricing, brand, gender, category, whatever. Like if you want to use some other kind of data sets, so for them all that kind of features, right? So this kind of gives us a structured and scalable way to manage our product catalogs. Okay. Then we have our LangChain in that valid box you could see, and this helps us to connect everything, like to from fetching the data, embedding the data, then storing it into a vector database, then running the retrieval process, and finally passing them to an LLM, right? And then comes up that vector database that we are using Pinecone in this video. Okay, and Pinecone is one of the best vector database out there. So what happens is we take the product data from MySQL and we pass it through an embedding model which turns each product description into a vector, and then we upsert that into a Pinecone database. Okay, so any product or update in MySQL, we sync it with Pinecone using a dedicated script which is like sync script, so our vector database will be always up to date. Okay, and then of course we have RAG for our user query data retrieval and LLM generation, and finally we to make that chatbot a bit interactive we'll be using Streamlit. Okay, so now that we understand the what's going to happen, so let's make it happen. Alright, so before we begin, make sure to download the dataset we'll be working with, and I have linked this Kaggle right below in the description. Just click it and sign into Kaggle and download the dataset from here. Alright, next we'll need a Google Gemini API key. So come into this URL aistudio.google.com/API key, have your API key with your Google project. Alright, and after that, as we are using Pinecone database for our vector storage, you need to sign up into this Pinecone database and create a new project and have your API key. Alright, and as I have said earlier that we'll be using a relational database to store our CSV files data, so we'll be using MySQL of course. So you need to have a MySQL software, either Workbench or XAMPP. I'll prefer you should have a Workbench because it's far more easy, and I'll be using Workbench too. Okay, so go into MySQL website and download your MySQL Workbench software. Okay, and after having all this key, all this database, we are good to go for the application. Alright, so here I have added my Google API key and my Pinecone API key into this .env file, and these are the requirement.txt file and these are the libraries that we have to install. Okay, so first, of course, whenever you are using some application using Python, it's always a better choice to create a virtual environment, right? So we'll be creating a virtual environment. So Python -m venv my-env. You can use conda if you want, but I prefer this venv for my general development purpose. Okay, so Python -m venv my-env, let it create the my-env. Okay, after that we need to activate our this virtual environment, right? So wait until it's given me the position. Alright, now we need to activate our virtual environment, right? So we'll write this command my-env, like whatever your environment name. So my-env / will come into the scripts /activate. And why we are writing this command, as if you could come into this mynb folder, you could see there is a script folder, and under this script folder we have this activate bat file. So we have to activate that. So mynv/script/activate. Let's enter. Alright, so now we are under our virtual environment. Now we need to install this requirement.txt. So we'll simply write this command pip install -r requirements.txt. Alright, and it will download, it will install all our necessary packages. Okay, it will take some time, so I'll come back after it downloads everything. Okay, alright, so we have installed all our necessary packages, and first let us check the dataset that we'll be using. Okay, here you could see that in this dataset we have our product ID, we have our product name, we have product brand, gender, price, description, and our primary color. And this will be the knowledge base for our dataset. Okay, for our chatbot, sorry, we have only 129 rows. So I have made this dataset smaller intentionally so that we test with the small dataset, and then when we'll be advancing with the application, we'll be using some more thousands of lines of rows of dataset. Okay, so after we are ready with our knowledge base in our CSV file, our next step would be to transfer this dataset into a MySQL table. Okay, so let me first open my SQL workbench, and if you are using XAMPP or any cloud based thing, just follow up with the thing and I'll be telling you where you need to use your credential. Okay, so here we'll be passing our password. It is password. Alright, so here you could see I have already one Shop Assistant where I was trying the application before. Okay, so we'll first create a new schema. So I'll be naming it let's say Shop Assistants. Okay, I have to give a different name. So Shop Assistants, I'll apply and finish. Alright, then we'll come into this query, we'll run this command use Shop Assistants, so that the pointer comes under this schema. Okay, now what we need to do, we need to create a table, right? So let's create a table. So create table products. Okay, under this we have our product ID, so product ID, which will be a data types of int, and I want to make it my primary key, so primary key. Alright, after that we need our product name, so product name, and this will be a form of varchar. Okay, varchar. Alright, so then product brand, right? Product brand, varchar again 255, comma, then we have our gender would be form of varchar. I can make it 50 because it will be maximum male or female, right? So gender done. Let's make it for the price would be for me varchar, comma, then description would be in the form of text. Okay, then the last column was with primary color, so primary color with the varchar of 50. Okay, That being said, we'll run this, and to run any particular query you need to select the whole query or place your cursor within this query and run this option which says that execute the statement under the keyboard cursor. We'll run it. You could see it has given us the signal that it has run successfully. Now we'll refresh the schema. You could see we have a new table here, products. We'll create a right click, we'll select on the select rows, and here you could see we have created our own table. Okay, now we need to insert those data. Right now, to insert those data we need, and we'll be inserting data from our Python file. We can easily insert like one by one by giving query for each and every data, but we won't be wasting our time on that. So coming in here, we'll create a new file as, let's say, data insertion.py. okay, here first we need to import some libraries, so let me just give a command. So import library. Okay, what we need to import? We need to import the most important MySQL dot connector. Alright, it's not showing me. Then import pandas as pd, then import os, then from .env we need to import our load.env. Alright, so it's saying that MySQL connector is not accessed, of course. Alright, import MySQL could not be resolved, so it somehow it hasn't been installed, it is saying. Alright, so let us just install it again. Okay, so pip install MySQL connector Python. Okay, let us run it. Alright, now let's check. It's still showing me that it's not working. Well, let me just close this application again. Alright, so we have opened the ID again. Now let us activate the environment. What happened? Acha, scr. Okay, alright, now the error has been gone. I feel now it's okay. Okay, so where we were importing our library. After that we need to call our this load.env function. Load.env, call the function. Okay, and this would kind of help us to load all our API keys that we have stored into this .env file. Okay, alright, so after that we need to kind of establish a connection to our MySQL database using these credentials. Okay, so for that first we need to read our CSV. So read CSV file. Okay, so for that let's say CSV path. I need to give it the path. Okay, read CSV file here. CSV file. Here I'll give the option, so shop product catalog dot CSV. Okay, I've got my CSV path. Then in data pd dot read CSV, here I'll simply pass my CSV file. Okay, Okay, it will be PD. Okay, so CSV file. Alright, now I'll save it. After that, alright, so now we have to establish the connection. So for that, connect to MySQL. Okay, and here it's a variable db connection. Under this I'll call my MySQL function. So MySQL dot connector dot connect. So see this carefully. So this is how you need to connect it. After that, we need to pass some parameter. So first parameter will be the host. So host would be localhost. Okay, and then user. And if you're using Workbench, you would know that Workbench gives you username and one password. So whatever your username is, provide that. In my case it is root, and most of the time by default it's root. Then we need our password os dot get env, and to get any kind of API key or any kind of password that you have stored in your .env file, the process is using os.getEnv, and then under first bracket name that particular, okay, db password. I haven't provided that into our .env file. Okay, so I'll come into my .env. Here I'll name it db password, and I'll name it sn004 MySQL. Okay, I have provided my .env. Now after providing password, we need to provide the database name. Database name means the database schema that we have created. You could see here we have named it as Shop Assistants. So we need to provide this over here. So Shop Assistants. Okay, now our connection will be done with this amount of code. Let us make it db. Alright, so after connection to MySQL, we need to create a cursor to execute our SQL commands to insert each and every row to our database, right? So for that we will first create a cursor. So cursor, so db underscore connection will create a cursor for our database. So cursor with this connection, then we'll iterate through our CSV file. So for index and row in my data dot iter rows. Okay, iter rows. So I'll iterate through my CSV dataset. Then this is my SQL query, 3 line. Here I need to write the query to insert my data to my database. So insert into, our name of the table is products. So products, insert into products. Then we need to mention each and every column name. Okay, so product ID, we have product name, then we have product brand, then gender, then price, then we had description, and at last we have primary color. Okay, so insert into products, then we need to provide the values, right? So values, and what will be the values? For the values we need to use this s comma %s comma %s comma %s %s comma %s. So we have 3, 6, 7 columns. So 3, 6, we need one more. Alright, so in each and every iteration I will insert these values into my MySQL database. Alright, after this let me just create the intention properly. Alright, so after this we need to execute our cursor. So cursor dot execute provide MySQL and tuple row. Okay, alright, so here I need to use cursor execute this. Alright, alright. Alright, so after executing our cursor we need to make sure that we are committing our each and every transaction, right? Because commit will kind of save your each and every query for the database, because if you don't commit any of your transaction, so it won't occur into the database. Okay, so we'll write db connection dot, we need to commit it, and after committing the transaction we need to make sure that we close our cursor and we close our transaction like our db connection. Okay, so we'll close cursor dot close, and we'll need to close this as well, db connection, sorry, db db connection dot close. All right, we'll save it and then we'll run it. And to run it, it's simple. How we run a Python file. So Python and the name of the file, so data insertion dot py. Let's see if there is any error or not. Alright, so there is not any error, so we'll come in here, we'll just run this query, and you could see we have inserted all the columns over here. Okay, if we move towards the bottom, you could see 1128, which is the last product ID, and in our CSV we also have 1128 as our last product ID. Alright, so we have inserted every data. Now to check how many rows we have, you can simply run this query, select count, we'll count as per our product ID cause that's the unique one. So product ID, let's just simple, yes, let's say number of rows from our products. Okay, we'll run this query. You could see we have 129 rows. Okay, now after inserting all the data into our database, we need to make sure that all those data goes into our Pinecone index, and we need to kind of create those embedded vector, and we have to store them into our Pinecone vector database. Okay, so now in next part we'll be doing that. Alright, so as we have done with our data insertion.py, now we need to create our sync pinecone.py, and this file will kind of help us to transfer our knowledge base from our MySQL database to our vector database Pinecone with embedding. Okay, so first we'll import our libraries. So let's say import OS, and we need to import time, then we need to import MySQL dot db MySQL dot connector. Then as we are using Google Generative AI embedding, so from LangChain Google Gen AI, I need to import Google Generative AI embedding. Okay, then of course from Pinecone, import Pinecone, as PineconeDB is a serverless vector database, so we need to import serverless spec. Okay, then to showcase those progress bar, we need to use tqdm auto. I'll import tqdm. Okay, and of course to load our .env variables, so from .env we'll import load.env. Okay, we'll simply load our .env, so we'll call the function, done. Then to initialize our Pinecone application, Pinecone configuration. Okay, what we'll do, we'll first get our API key, right? API key os dot get env, sorry, Pinecone API key. All right. Okay. Now we need to initialize our application. So in the PC variable, I'll simply call my Pinecone. Here I'll pass the API key which is API key. Okay. Then again, as I mentioned earlier, that it's a serverless vector database. So we need to call that too. So SPC will call serverless spec. We'll pass a couple of parameters as which cloud we are using, and in this case it will be AWS, and which region of AWS we are using. It will be US East 1. You should check what is the default for your application for your PineconeDB. Okay, so this was done. Now after that, let me first show you my Pinecone dashboard. Okay, so here it is. You could see we are storing all those vector embedding in this indexes. So we need to create my index, and there I'll be storing all my embedding vectors, right? So let me first give a name to my index. So index name would be, let's say, shop product catalog, right? Not underscore. It's better to give hyphen. Okay, so I kind of first I need to fetch all the indexes that I have in my Pinecone, in my own Pinecone database. Okay, so for that, what I'll do, I'll first fetch all my existing index. So existing index. Here I'll run a loop. So for index info in pc dot list indexes. So every index I have, I need to fetch index info with the name. All right. After getting all the index names, I need to check that the if the index name I want to create, if it's already exist or not. So check if index is already exist, right? So again, simple, we'll use if my index name not in existing index. Like if it does, we don't need to create, but if it doesn't, then we need to create. And how to create, we'll use pc dot create index. Then we need to pass couple of parameters, and we have mainly 4 parameters as the name of the index, which will be index name, of course. Second, the dimension, which will be in my case 768. And why the dimension is 768? Because the embedding model that we are using, which is Google's embedding hyphen 001, and that embedding model kind of gives an output of vectors with the dimension of 768. Okay, and the metric will be dot product. As you know that we use dot product to combine matrices to get values. So dot product. Then for serverless, to provide in which region, in which cloud we are using, SPC. Okay, so there is one more thing to do, that this creation of index might take some time, right? So for that, you need to give this application a bit of time, so that it will first create the index, and then it should move with its next codes. So for that, I'll use that time.sleep process, like how we use async await in JavaScript, right? So that to give some extra time to my code. So while not in pc dot describe the index, like I need to first have the description of the index of my index. So describe index. So while not in pc dot describe index with the name of index name, and we need to have the status of it. So status, let's say ready. Okay, if the description of my index name is not ready, sorry, okay, we don't need to give it in now, right? We are using loop. So while it is ready, okay, so while my index is not ready, I need to sleep my application a bit. So time dot sleep. After this ready, we'll simply will connect to the index. Okay, and to do that, index will be, we call this index. Okay, okay, not this only index, we need to use pc dot index. I'll simply pass the name, so it will get connect, and again for a time we'll give it time dot sleep 1. Okay, so our pinecone configuration is done. Now we need to add the configuration for our database. So I'll simply copy this one, this whole code will come over here. I'll paste it over here. Okay, so the MySQL connection is done. Now we need to kind of configure our Google Generative AI API, right? So yeah, okay, so we have two, we have our LM, we have our embedding, right? So OS dot environment, we are taking Google API key, and how you're gonna have it again, OS dot get env, and here we'll simply need to pass our Google API key. All right, so after that we need to have our embed model. So embed model, where I'll call my Google Generative AI embedding, and I'll simply pass that which model I want to use, and the model name will be models slash, as I said, embedding, it was embedding hyphen 001. All right, so now we only left two things to do. One, we need to fetch all our data from our MySQL database, and secondly, we need to convert those data into embedding vectors, and we need to upload them, right? So for that, let us create two function. Let's say def fetch data. Okay, and we'll be needing another one. As sync with Pinecone. Okay, where we'll be passing the data that will be fetching from our MySQL database. Okay, so first create the fetching function, right? So here, so to fetch, what query we use? We use this simple query, which is the basic of SQL query. Select, will use star from our all the products. Okay, is that simple? So having that query, we need to execute this query. So we'll use cursor dot execute, will pass through our query through it. Okay, and cursor kind of helps us to execute individual queries. Okay, and then in columns, I'll create a data frame to store those data. So data frame. All right, I think I haven't imported pandas, so import pandas as pd. Okay, so here pd dot data frame, where we'll pass our cursor dot fetch all. We'll be fetching all the data, and in columns we'll provide our columns. Okay, all right, so after that we need to get the we need to get the data. So okay, where is the mistake I've done? I first need to fetch the description in the column, right? So in column, let me first just run a loop. So from dsc in cursor dot description. Okay, and through that I'll be taking all the indexes in my column. Okay, now having that column, I need to create the data, and to create the data I'll be creating a data frame over here. Data frame where I'll simply pass my cursor dot fetch all, and also I need to provide the columns. um, Column should be columns. All right, and then simply return the data. Okay, and we'll pass the data into this sync with Pinecone function. Okay, so the first thing we need to do in this function, that we need to make sure that whatever that how many amount of rows we have, we need to break them into multiple batches. So we have around 129, but still the kind of basic practice you could see to use a batch size of 100. Okay, and using that we need to first calculate the total amount of batch size that we would be needing, where we'll be using batch size of 100. So total total batches, so batches. Okay, here let us create that. So first we need to get the length of the data, so len data. Okay, then we'll pass, then we'll add our batch size, and we'll which is -1, then we'll divide it with amount of batch size. Okay, then to process each and every batch, will run a for loop. So for, let's say, I in, and as I mentioned earlier, that tqdm library kind of helps us to showcase the that process bar, that processing bar, right? So for I in tqdm, let me showcase the range that the tqdm have to use. So the range would be 0 to len data. All right, and after len data I need to pass the batch size as well. So batch size, and after that I need to provide the description for that. So description would be processing batches, sorry, processing batches. Okay, and we need to also provide the parameter of unit, and this unit would be batch, and this batch is a kind of the sub unit of batches. Okay, and after that the amount of total batch you need to provide, so total, need to provide our total batches over here, and that's it. I'll use the column, then I need to define this. Okay, so first I need to have the end index of my data. So I end, I'll use minimum of the len data. Okay, len data, and I'll pass I plus the total batch size, total batch size. Okay, now as we are having, so it will be I end. Okay, as we are having batch, so I need to define the batch. So the batch would be data dot, we'll be using iloc, where we'll simply provide I is to I end. Okay, all right, so now we have defined our batch. Now we need to generate some unique IDs to kind of store those data into our Pinecone database, right? So unique ID, so to do that I'll create a variable IDs, I'll simply use this for loop for, let's say, blank and row in how many batch dot will iterate through all the batches, so iterate through rows. Then to that we'll be having row of product ID, so product ID. Okay, and then we need to convert that into a string. Okay, we'll use there, we'll use one over here. It won't be in caps, str. Okay, so we're done with our IDs. Now after that we have our unique ID. Now we need to combine all of our other text fields, and we'll combine the text fields and we'll, so that we can convert each and every text field together in a embedding vectors. So we'll combine text fields, let's say, for embedding. Okay, okay, now to do that I'll take a variable text. Here I'll combine that. So here I'll use f string to combining. So here let's say f string, so this first, then this, right? So row of, we have description, right? Then we have row of, we have product brand, right? Product brand. Then we have row of gender. Okay, then we have row of price, and we have finally row of, I think, primary color. Primary color. So we have 1 2 3 4 5, 1 2 3 4 5. So we forgot to add the name. So after this, so we need to add this over here. This, we don't need this one over here. Okay, so after that we need to add another one, which is row of product name. All right, so we have description, product name, brand name, gender, we have our price, we have primary color, right? Now to combine this, what I'll do, I'll simply use for every row in patch dot iteros. Okay, all right, now we need to embed the text. So embed text, to do that we'll use this variable embeds, and here we'll simply call our embed model. So embed model dot, we'll embed the document, so embed documents, and we'll pass our all the texts. Okay, now after kind of embedding all the thing, we need to kind of retrieve our metadata for each and every row, with their column. Okay, so get metadata, and for that I'll store the metadata into my metadata and create this. Now here I need to provide the name, so product name, this should be my row of product name. Okay, comma, I'll just copy this one and I'll paste it a couple of times. Okay, so then just change the name. So after product name, we might use product brand. Okay, we'll change the name to brand. Then we have gender. So gender, change the gender. Okay, then here we'll have price. So again, change it to price. And finally, we have our primary color. So primary color. Then we are forgetting one more thing. Actually, we have forgot to add our description. So come over here, description, same for this description. All right, now to add them, we'll again use for every row in patch dot iter rows. Okay, so we'll be having our all the metadata over here. After that, we need to assert vectors. Okay, and to do that, we'll use our tqdm to showcase the progress bar. So with tqdm, we'll pass the total. Let's say total will be my length of those unique IDs that I've created, right? So length of IDs, and I need to provide the description, and the description will be for, in this case, asserting vectors, and unit to be my vector, which I have used patch in the previously, but this time it will be vector. As for a simple alias, let's say assert vector or assert vector. Okay, all right. So now index dot, I'll be asserting them. So in index dot assert, I'll pass my vectors, which would be, I need to zip it. So zip of my, I'll provide my IDs, my embedding model, and my metadata. Okay, okay. After that, offset vector dot update, I'll simply pass my length of total IDs. Okay, all right. So my syncing is done. Now I simply need to define a main function where I'll call those functions. Okay, so we have data. I'll be calling my fetch data, and then I'll call sync with Pinecone, and I'll pass the data. Okay, then to initialize, if main, here simply call the main function. Okay, now after doing all of that, we simply need to close our cursor and our connection. So to do that, cursor dot close, and the DB connection that we have dot close. Okay, all right. So we'll save it, and we'll come here and we'll run the file. So Python sync pinecone.py, we'll run this, and let's see if there is any error or not. All right, so you could see processing batches, and we have upsorting vectors, and these are the description that I have given over here. You could see upsorting vectors and processing batches, right? So the uploading is done. Now will come my Pinecone vector. I'll refresh this page, and we should see my new index over here. Okay. All right, you could see shop product catalog, where my write up also got bit increased. Okay. Now I'll come over here, and here you could see total like record count 129. This was the metadata that I was providing. Okay, for 1 2 3 we have all those vectors. Okay, now back to the indexes. Now in our next step, we'll test this vector database and we'll try to retrieve some information from them. Okay. All right, so now we'll create a notebook to see how to integrate with Pinecone vector database with our Gemini LLM, and to how to retrieve some information from our vector store. Okay, so I'll create a IPNB file. Let's say I'll name it as integration.ipynb. Okay. All right, so in the first column, of course, we'll first have to configure our Pinecone environment and all those things, and I'll be taking help from my previous file, so I'll just copy all of them, paste all of them here. Okay, and I need to kind of first configure my Pinecone environment, so I'll just copy this, I'll paste it over here. Okay, and then I need the index names. Okay, so I'll copy this, then I'll paste over here. Okay, and I don't need this existing index because we are not creating anymore, because we have already created that, right? So here we have done, we have, so I don't need this time and this thing. Okay, let's just keep, I don't need the connector, so I'll just cut it. Okay, I won't be needing TQDM, so I'll cut this. Okay, no need of time. OS I'll be needing LangChain, Google Gemini. I am needing this over here. Pinecone, okay. .env, okay. No need of pandas. All right, so we are configuring our Pinecone. We are using our serverless, then the index name. Okay. Okay. So after the index, we need to simply connect it, right? So connect to the index, and for that, let's say my index would be pc dot index. I'll provide my index name over here, and simply then I'll use time dot sleep. Okay, so I don't need to import the time, right? So import time. Okay, so we have configured our Pinecone environment, we have got our index name, then we are connecting this when we are slipping it. Okay, so I'll run this file. Okay, this one. So, and you might need to install ipynb kernel, because we are running this ipynb file inside this mynv. Okay, so see what it says. All right, so it's done. Now what we need to do, we need to configure our embedding model, right? So again, I'll just copy this one, I'll paste it over here, and I'll use load.env again, and I'll simply call my this Google API environment. So I'll just copy this two line, I'll come over here, I'll paste it over here. Okay, so Google API key embedding model, I'll run it. Done. Okay, and after that we need to initialize Pinecone vector store. Okay, and this will help us to connect our Pinecone index with our Google generative AI embeddings. Okay, so for that, from LangChain Pinecone, so from LangChain Pinecone we need to import our Pinecone vector store. So here is its Pinecone vector store. Okay, so we'll create a variable as vector store. Here I'll call my Pinecone vector store. Okay, we have to pass some parameter. So wait, pass some parameters like the index that I want to provide, which would be my index, and the embedding would be my embed model, and text key would be description. And what's this description text key means? As key that as I said earlier, that we have to connect our Pinecone index with the Google generative AI embeddings, and we need to specify that the description field from where our product data will be used for those vectorization part, right? So I'll be showing you what I'm trying to say. Let me first run this. Okay, so after that, what we'll be doing, we'll be ask it a query, and we'll ask it to, hey, give me the relevant chunk from my vector store. Okay, so let's say first ask a query to it. Okay, and to get the query, let us first see our data set. So we have this um, let's say some easy thing. So we have this product of superstar bowl 2, right? So let us ask that what is the price of this superstar bolt 2. Okay, so I'll just copy this. I'll come over here. So what is the price of this product? Okay, I got the query. Now I need to connect that to my vector store. So vector store, and here I'll perform a similarity search. Okay, so as per this query, I want it to give me some relevant chunk. So I'll provide the query, and the chunk I will be needing, it will be 1 for this case. Okay, all right. So now let us run the cell, and we should see some document metadata. All right, you could see, no, you could see we have document ID 1042, metadata gender main, price 11 triple line. You could see over here we have superstar bowl 2 Adidas 11 triple line, and the description, where's the description? Okay, classic basketball shoes with a modern twist. Okay, so it is kind of giving me the chunk properly. Okay, so after that we need to add some system message, and we need to add our Google API key, so that as per the query I want some proper formatted answer, right? So for that, let's say first import with, then import Google dot, sorry, os import Google dot generative AI. We'll take it as Gen AI. Okay, simple load the .nb file, and let us create a chat history, so that my chatbot understand the context of my previous questions as well. So I'll run empty array chat history with done. Then I need to provide it a system message. Okay, so as of now I'll be giving it a very simple system message. So um, let's say acts as an shop assistant. Wait. I need to provide the quotation. So right, acts as an shop assistant and provide relevant response user query. Okay, a bit simple to check if the application is working or not first. Okay, so after the system message, we need to create a function that will help us to kind of generate the response from our Google Gemini. So I'll be taking it in a new cell. All right, so in this new cell, I'll try to get a function to kind of get the response from my Google Gemini API. So def gen answer. I'll have to provide the system message and the chat history to keep the context, and the prompt. Okay, colon. Now to call my to configure my generative AI, so GenAI dot configure, I'll provide the API key. Now I'll be directly getting that over here. So os dot get env, I'll simply call Google API key. Okay, after that again we have to provide the model name that we are using, model GenAI dot generative model. Okay, here Gemini 1.5 flash. You can change as per whatever model you want to use. Okay, then after configuring that, I need to append the new prompt to the chat history, because my application should know that what prompt my user is also giving, right? So append prompt to chat history. Okay, so for that, chat history dot append user, I'll simply provide the prompt. Okay, so after that, we need to combine the system message with this chat history, right? Of course, again, to give my bot some more context, so combine system message to chat history. Okay, so how we'll do that, we'll create a new variable as full prompt here, f string. I'll use the system message, and then /n to get a new line, plus /n. Okay, then we'll simply join it. Okay, there was another one over here. Okay, we'll use join, where we'll pass our chat history. And again we'll be merging it with my assistant. Okay, and this assistant is my chatbot, right? So now after combining that, we need to generate the response. So generate response here. In response, I'll store model dot generate content. I need to provide my full prompt over here. Then I have to convert that into text. Okay, then I need to add that to my chat history. So chat history, dot append. Here I'll simply turn my assistant, which would be the response. That's it. After that, simply return response. Okay, just run this cell. All right, now what we need to do, we need to see, after generating the query, we would like to see that what are the relevant passages that my bot is kind of retrieving from the vector store. Okay, to see that if it is really retrieving the real information or not. So get relevant chunk. So I'll pass the user query over here. I'll pass my vector store over here. Then what I'll do, in the results, I'll call the vector store. I'll use a similarity search as I showed earlier, where I'll simply pass query. And as of now, I'm tend to retrieving only one chunk. You can use it multiple if you want. Okay. If if the results is there, then we need to gather its metadata, right? So result 0 dot metadata. Okay, so results 0, so the first index of the result, then the metadata, then I have to give it the context. Okay, and in the context I need to provide my product name, brand, price, color, description, and its metadata. Okay, so let us do that. So product name, then simply my metadata, dot, I use get function to product name. And as we are taking only the description from my vector store to kind of generate the answer, so I'll make this as not available. Okay, and it will be pretty much same for the rest. So what I'll do, I'll just copy this and I'll paste it 4 times. Okay, and let us change the name. So this will be the brand, this will be the price, this would be my color. Okay, so as per that, change it to brand. I'll be changing it to price and color. Okay, now for the last one, we have the description, because description is what from where we'll create our answer. So description, metadata. Now here what we'll do, rather than using metadata, here we'll retrieve the real value of it, right? So results of index 0 dot page content. Okay, page content. All right, now after this context, we'll need to simply return the context. Okay, and then we'll return the, if there is no result, then we'll simply return that no relevant search. Like if we got the result, we'll do this part, and if we don't get any result, we'll show key no relevant search, right? Simple. And then let's say we'll have to create another one to create the prompt for the chatbot. So make prompt. Okay, so here we'll simply pass the query and provide the context. Okay, will return a string query, which would be my query with n context given, some the context that I have, and again, and finally I'll be having my answer. So answer. All right, I will save this. All right, so now we'll create a main function, and here we'll bring together all the components we have set up. Okay, so let us first create that def main, then let's say a query. So let first copy this, query. What is the price of the superstar product? I'll paste that over here. Okay, and then I'll first bring the relevant text. So relevant text, here I'll call the function get relevant chunk, and I'll pass my query and the vector store. Okay, after that I need the prompt. So in prompt I'll use my make prompt, and there I'll simply pass my query and the relevant text that I have. Okay, now I need to generate and I need to print the final answer, right? So in answer, what I'll do, I'll use the generate answer function. Here I'll pass my system message, then I'll pass chat history, then I'll pass prompt. All right, then simply print answer. Okay, then answer. Okay, so let us first run this. So for that, if I'll initialize this, okay, and I'll simply call this function. All right, now I'll run this. Okay, there is an error. It's saying no name get relevant chunk is not defined. Okay, I need to run this cell first. Now I'll run this one. You see, answer assistant, the superstar bolt 2 is priced at 11,999. Okay, now now we can use some, like continue interaction query. Like as per my first query, my application should understand the context and it should give my next answers question, my next question's answer. So superstar bolt 2 product has a classic basketball shoes with a modern twist, right? So I might ask the question that which sports that like superstar bolt 2 has been used. Okay, so superstar bolt 2, okay, so let's ask different question. So we'll ask query 2, where I say ask can you tell me about the um, product brand of this shoe. Okay, so after that, what I'll do, I'll simply again call my relevant text to. I'll call the function get relevant chunk. I'll pass query to. I'll pass my vector store. Okay, then for prompt to, I'll call that make prompt. I'll pass query to, I'll pass relevant text to, and then I'll need my answer to. Here I'll call Gen answer. I'll simply pass my system message, and I'll pass my chat history to get the context, and the prompt to. Okay, then simply print it, right? So answer to. Okay, now let's run this. The superstar bolt 2 is cost. So I'm sorry, but the brand information for the float rate energy shoes is not available to me. Alright, so it's not getting the particular information. So I think the problem lies on the my system prompt. Okay, so product brand, it is Adidas. So what is the price of the superstar bolt 2 product? Can you tell me about the brand of this, let's say. Okay, so it's gonna understand this. So if I just copy this one, and if I just place it over here, and then if I run it, then by the brand information from, okay, so I think I need to give the name of it. So product, let's run this. All right, got it. See, that's the problem. I am only taking the information of description. Okay, so for the product name, brand, price, color, I am not taking any context of it, right? So we need to ask question related to my my description. Okay, so um, for that, let's say, can you classic basketball with a modern twist and bold design? Okay, so can you tell me about the design of this product? Okay, let's see. Okay, the Stan Smith shoes have a classic and minimalist design. Again, it's not getting the answer properly. So I need to change the prompt now. Okay. All right. So what I'll do, I'll simply change the prompt. Okay. So we have this system message as acts as a shop assistant and provide the relevant response as per the user query. So now to kind of cater more dynamic question, we need to provide some more powerful system message. So I'll give this system message. You could see if a query lacks the direct answer, durability, generate a response based on related features. Okay. Now what I'll do, I'll simply run this cell. I'll again run this cell, and now I'll have this. Okay. Now finally, you could see what is the price of the Superstar Bolt 2 product, and can you tell me about the design of this product? And what's the design? The design is, it has a classic basketball shoes with a modern twist and bold design, right? Now we should have got some more processed answer. Okay, so now we'll run this. You could see answer. Hi there, the Superstar Bold are priced at 11,999. Is there anything I can help with? Hi there, the Stan Smith have a minimalist design which is really classic and timeless. Anything? Okay, so that's how you can do it. So this system prompting gonna help you a lot. So with more powerful prompt, we're gonna have some more dynamic questions answer. Okay. All right. So now that we have explored how effectively our chatbot is processing the queries and is kind of providing us the responses. So now we shall create a Streamlit interface for a better use cases of it. Okay. So I'll just simply create an app.py. Okay, here what I'll do first, I'll just come in this IPNB file and I'll tend to copy the function from here. Okay, because it will be a 90% of same code. So I'll just copy this, I'll paste it over here. Okay, I need to import a lot of things, so just wait. So we'll import couple of things. We'll load our .env, Pinecone configuration, serverless, index, my index, connect to the index. Okay, then what do we need? Then we need our Google API key. So we'll come over here, we'll just copy this code, we'll paste it over here, but we don't need this load.env. We'll cut this from here, we'll paste it over here. Right, now my Google configuration is done. Now after that, I'll be needing to initializing the vector store. So simply copy this, paste it over here. The import should be at top. Okay, this is done. Now we need to, as you could see over here, we have initialized an empty chat history, but in Streamlit we need to create a session state to kind of store all chat history over. Okay, so if chat history, um wait, it will be under quotation. So if chat history not in my ht dot session state. Okay, what I'll do, I'll initialize a session state. So session state dot chat history, initialize one. All right, I need to import Streamlit first. ht. All right, okay, so after that we need to paste our system message. Okay, so I'll copy this one, I'll paste it over here. Now we need to add those functions. Okay, so first we need to add those functions to generate the response from our Google Gemini. So I'll copy this, get answer, paste it over here. Then I'll be needing the function to create those relevant chunk. Okay, so I'll copy this, let's paste it over here. Alright, there is some error, it's saying Gemini AI. Alright, so we have to use this import statement. This will be adding this over here. Okay, alright, so we have added our relevant chunk, our get answer, our make prompt. After that, what we need to create the Streamlit interface. So ht dot title, let me just add shop catalog chatbot. Right, then I'll be needing a query, and to get the query I'll use ht dot text input. I'll say ask query. Okay, now I'll use a button, so ht dot button. So if ht dot button, if someone is clicking this, okay, so if someone is clicking this button, then I'll, in this if block, if I have the query, then I'll I'll add those process of retrieving the data. Okay, so I'll be having that relevant chunk, so relevant text, I'll call my get relevant chunk. Here I'll simply pass my query, I'll pass my vector store. Simple. Okay, the query query. After relevant text, we need our prompt. So for that, I have make prompt, where I'll simply pass my query and my relevant text. Okay. Then to generate the answer, in answer, I'll use gen answer, where I need to pass my system message to get a better context. Then ht dot session state dot chat history, not only chat history, dot chat history, and of course we need to provide the prompt. Okay, and then ht dot write answer answer. Okay, now I need to display the chat history. So to display that, I'll use let's say with ht dot, I'll use a expander form, so that after expanding, you'd get to see the chat history. Expander, here I'll provide chat history. Okay, so if someone expand that box, then for chat in ht dot session state dot chat history, I'll use ht dot write my chat. Okay, I'll simply save this one, and after that I'll come over here, right, Streamlit run app.py. Let's see. All right, okay, now let's see what query we may ask. So shop product catalog CSV, let's say we have this lightweight, what should we ask? So we have this authentic product name with product brand Vans, this 1012. Okay, so classic tech shoes with a relaxed fit. So let's say what is the brand name of authentic, so what is the price of authentic, right? So let us ask this first. So authentic, right? The authentic pro is priced at 4999. Let us see if it's right. It's saying 3999. I think there should be another one, authentic light, so there should be an authentic pro, right? Authentic pro, only 499. Okay, so it's taking that one. Okay, so describe authentic products, right? So I'll say good answer, and let's see. The authentic shoes are classic shoes known for their relaxed fit. They are 399. Anything else I can help you? Okay, so it's giving you the answer as per your query, and that's being said. This was the basic application of kind of using RAG in our real life, where you can use this application for your shop catalog and shop assistant. Okay, so I'd want all of you to give me some more idea that I might implement to make this Shop catalog chatbot more advanced. So comment your suggestion. Okay, and yeah, thanks for watching.